Okay, so last video we're going to work on solving some problems that involve geometric sequences. We have a phone tree. So yeah, let's talk about the phone tree. A phone tree is when one person calls a certain number of people, then those people each call the same number of people, and so on. In the fifth round of calls, 243 people were called. Write an explicit definition to find the number of people called in each round. Okay, so what do we know? Well, we know, looking at the picture, here's our first person. They call 1, 2, 3 people. So in the first round, we call 3 people. So we know the first term is 3. We also know that in the fifth round, that's going to be A sub 5, we call 243 people. What we don't know is the common ratio. So we're going to use what we know and solve for what we don't know so that we can write an explicit definition for the situation. So what that's going to look like is we are just going to follow our explicit definition. AN equals A1 times R raised to the n minus 1 power. And we're going to plug in the things we know. So we know that the first term is 3. So here's my 3 times. We don't know the ratio, common ratio. And then we know that the fifth term is 243. So when the fifth term is 243, that 5 is our n. So I'm going to plug that in for this n right here. So 5 minus 1. And the fifth term is 243. So that's what goes over here, 243. Now we can solve for our unknown value of r. So we have 243 equals 3 times r to the 4th power when we subtract 5 minus 1. Let's solve for r by dividing by 3. Bring this over here. That gives us 81 is equal to r to the 4th power. And then we learned in a previous unit how to solve for r, how to undo the 4th power. We can take the 4th root, or we can raise it to the 1/4 power. Maybe if we don't know this off the top of our heads, 81 to the 1/4 power is the same thing as the 4th root of 81. Because we are taking an even root, mathematically there are 2 solutions, a positive and a negative, but our ratio will be positive, so we'll disregard the negative answer and we get a common ratio of 3. So now we can write the explicit definition. We're going to follow this right here. AN equals, we know the first term is 3, times, we know the common ratio is 3. That's what we had to find, and we raise that to the n minus 1 power. And there is the explicit definition for the situation. Okay, so part B, how many people were called in the 8th round of the phone tree? So the 8th round would be A sub 8. So that's what we have to find, is A sub 8. So we can use our formula, or our definition that we created. So A sub 8 equals, remember that 8 is what we're going to plug in for n. 3 times 3 raised to the 8 minus 1 power. That's how we find the 8th term. 8 minus 1 is 7, so we have 3 times 3 to the 7th power. And then just don't you dare multiply before the exponents. We are going to do 3 to the 7th power first. 3 to the 7th power is 2,187. And when we multiply that by 3, so you just have to make sure you're following your order of operations, we get 6,561 people that were called in the 8th round.